Hi everyone, we're going to do a quick presentation on tuning of PID controllers, and then we will demonstrate the application sharing software. I just want to welcome Luke and Rick. Rick's a few hundred kilometers south in Bunbury, and we've got Luke in London. Luke will take over the application sharing software once I've done this quick demo. Can you please confirm that you can hear me, Luke and Rick? Over to you, Luke.
Hi Steve, coming through loud and clear.
Yep, Steve, hearing you fine. Looking forward to this. Off you go.
Thanks very much, guys. Okay, tuning of PID controllers. I just want to ask you guys, if you can just text me, have you ever used PID controllers before, Luke and Rick? If you can just confirm that you've worked with them or not, just give me a quick text message while I just kick off. Okay, Rick's a little bit, and Luke, have you done tuning? I think you were involved in the design of one of the PLCs, weren't you? That's great. Okay, good. Okay, so objectives obviously minimize integral error, and the next objective is really that we want to do is minimize wear and tear, and no overshoot at startup. So the model that we're going to use is this one here. This is the controller. This is what we're going to be working with, and we're going to have the whole process simulated. So I'm going to pass this over to Luke, who's going to actually run the model. Luke, are you able to run the model with application sharing? I want you to take over the model in the next session. I'm going to pass control over to you, and I want you to then describe what you see with the model. We're looking for P, I, and D. Can you tell me, Luke, what P, I, and D mean? Over to you, Luke.
If I remember correctly, P is for proportional, I is for integral, and D is for derivative, and they all relate to the distance between the actual required value and the actual measured value.
Brilliant. Okay, that's great. Okay, what I'm going to do now, Luke, is I'm going to run the application sharing PID software on my machine. I want you to take over and describe what you're seeing. So you will now take over and run the model. So over to you, Luke.
Thank you, Steve. I will be demonstrating the remote desktop features within Electromeet. At the moment we have a process control simulation package called PID Controllers 3 running on Steve's desktop. You should be able to see the screen rolling across in a time span, as well as having the degrees of the actual process that is being intended to simulate from top to bottom. At the moment I'll press it into manual mode and attempt to generate changes in the load by moving the little white arrow on the right of the screen up and down. As you can see, the temperature in the process is actually moving up and down, but not actually generating any difference in the process variable or the output of the controller. In a moment I'll actually switch it onto automatic mode and show you the generated response output. As you can see, this is actually being shared across all three participants in our session. So we've found that it actually scales up really well, so you can share your screen amongst most people available. I will switch it into automatic mode now and generate a change in the load. You should be able to see both the output and process variable begin to change, as has happened here. So now on the right screen you can actually see the process variable settle about the intended level of the actual load itself. So after generating these responses, we can show that this enables us to basically demonstrate a local running software package in a distributed remote fashion, which will be extremely helpful for those that need to demonstrate engineering or software packages. We've actually used this technology in some of our courses to demonstrate features of MATLAB, as well as obviously PC Control Lab, programs such as Wireshark and other various formats. And anyway, thank you for your time, and hopefully you will see how flexible our system can be.